Hi, my name is Dustin Shahidehpour. I'm an engineer on Facebook's app architecture team, and today I'm here to talk about the modernization of Facebook's app architecture. So first things first, a little bit of history. Facebook has had an app in the App Store for about 15 years. And for the first 3 or 4 years, it was only maintained by a single person. It was largely a web view that showed up in Safari. About a year later, when Apple released UI View and kind of like native things you all know and love now, we rewrote the app to use that. But around 2010, there was this question internally. We had one guy who was literally building all the screens natively for all the different teams. And then we had hundreds and hundreds of web engineers. So we said, HTML5 is coming out. Why do we have one engineer building native? Let's just trash this native thing. We can write HTML5, write it once, use it everywhere. So we tried it. And we began testing it internally in the beginning of 2011. And it was very noticeable how much worse the performance was when you go to non-native. There's a well-known documented delay in Safari for touch handling in the browser versus native touch handling. So you would tap to scroll and there'd be a hesitation. We released it to the public. User reviews were very similar. They noticed the performance degradation. And right around that time, Facebook was trying to IPO. And if you look on the bottom right of the slide, you can see there were a lot of questions about the mobile app. We kept rewriting it, relaunching it. The latest iteration seemed to be the least, like the worst one yet. And so there was just a lot of questions. So finally in January 2012, Facebook decided to buckle down, start hiring native engineers, went into Xcode, started a new Xcode project called Wild, named after Oscar Wilde. And that's the code base we still have today, 10 years later. So this is what it looked like to integrate a screen or a product into the Facebook app around 2012. First thing is you would register your product by subclassing FBAppModule. And then during app startup, we would iterate through all the classes in memory, find the ones with subclass FBAppModule, and initialize them. Each module would be given a key or like an ID, and we use this for navigation, for analytics, anything that needs an identifier. This was it. And then lastly, we had all these different sort of optional interfaces that you could conform to say, oh, well, my screen also does force touch handling, or my screen also does, prefetching or something. And this worked really well in the beginning. All the product code was co-located. It was easy to find. Based on the naming convention, it was easy to find which module you were going to work on. Life was good. Unfortunately, this did not scale. One of the first problems we ever noticed with FBAppModule was here inside of this init with context method. Engineers began to notice as a side effect that this init with context method was being called very early during the app startup, and would use this method to do other things besides initialization because it was happening early. They would use it for prefetching data, for loading assets off disk, things to make their product feel snappy. Unfortunately, this had a huge effect on our app startup time. So that pink bubble is where we're going, finding all the classes which subclass FBAppModule, initializing them. As we start to add more modules and people started prefetching more things, this ballooned, and the Facebook startup time was 30 seconds on the iPhone 4. And if you broke it down, you could see that every single module was total tragedy of the commons. There was ungoverned access to the main thread. We all suffered for it. The second issue that we saw with FBAppModule were runtime failures. So as I mentioned earlier, every module has an ID, and we would use these for navigation. So if you ever went and looked at our navigation code, this is an oversimplified piece of code, but you give it a context and you say, hey, here's my context. I'd like to go to groups. And it would go look inside of a registry, and it would say, okay, I didn't find a module named groups, so I don't know where you're going, so I'm just going to crash the app. And inside of Facebook, this was rarely a problem, but this became a nightmare once we started rolling out other apps. So we had an app called Moments, which was a photo sharing app. We had an app that was just groups, and so you can imagine in the Moments app, they just had photo module. And in groups, they only had the groups module. Well, one day, somebody added support for photos and groups. So there was a method in there called did tap group photo, and inside of the code, it would say, go to the module with the ID photo so that you can view the photo. But the issue is, in groups only, there is no photos module, so that code would crash. And there was no way of really knowing that unless you started to test every single path, and this is just like a combinatorial explosion of going from one module to the next. So what engineers started doing to get around this problem was they wouldn't use the navigate to module by ID method. They would just start having direct dependencies on each other. So they would say, no. I'm not going to view the photo in groups by using the go-to module with identifier. I'm just going to depend straight on groups, depend straight on the module, and then call it myself. So problem solved, right? Who needs the navigate to module ID? No, doesn't solve the problem. Everybody started depending on everything, and then suddenly the Moments app is not just photos, it's got every module. You may not be able to get to all those screens. Groups only has groups, but groups connects everything. So suddenly Moments, groups, and groups only all have the same amount of code, and really the only difference between them is how you have access to navigate from one screen to the next. There were a bunch of other issues with FBAppModule. We only have 20 minutes, so I can't keep going into it, but let's highlight the 3 most important ones for this talk. 1, startup time is suffering because everyone's prefetching, loading assets from disk, doing stuff during app module initialization. Next, the runtime failures from all the navigating to modules, the combinatorial explosion. It was impossible to test as we kept making these smaller apps. Last, to solve number 2, everybody is creating modularity problems and forcing everything to depend on everything. So in 2016, we were building everything natively. We were rolling out new features. We just hit a complete breaking point, and it was time to just rethink FBAppModule. First thing we did was we got rid of the initializer method. The point of that originally was to hand you the context so that you could store it if you needed it. And then during all the other methods like navigate to screen, prefetching, whatever else, force touch handling, you had it. But we decided, okay, we can't leave it upon them to cache it because they use this method for other things. So let's trash that method and pass you the context to every method, okay? Product teams notably complained, as they should, because now the product performance is bad because there's no place to prefetch. So what you do instead, we introduced a new prefetching API. So the key around this prefetching API is that there's an actual contract. It's not just a carte blanche method to do whatever you want. So as you notice, we pass you a context, but then we expect you to give us something back for the prefetching. And the power around this for our infra is that we can prioritize which modules get this thing called first, which tokens we might fire, things we want to cancel. There's all kinds of things we can do when there's a designated synchronous API for it. Eventually we started to realize, the app modules just had no state because there was no initializer. It was just a grab bag of functions. So we moved away from making them objects and we started making them just plain old functions, like a bag of C functions. On the right, that's how we would replace it. And then to wire everything up and get rid of the whole startup part where you would iterate through all the classes in memory, find the things which are subclassing FBAppModule, that's all gone. Instead, we would hard code it into a mapping. And so this was just built into the app's data section right when you start it up. So there's pros and cons to this approach, right? One is no more NS objects. It saves us a bunch of obfusc metadata, keeps the app size a little bit at bay. No runtime object discovery. That was really big for us because at the time, conforms to protocol was showing up in traces as being slow. It was one of the many reasons, not the only reason, one of the many reasons startup time was so slow. And finally, having the stateful objects kind of done away with and having synchronous contracts, pure functions, made it a lot more easy for us to reason about what was going on inside of certain functions and for teams as they were integrating. But the downside is, this doesn't look like idiomatic iOS development. Engineers are like, what are these mappings I have to update? Like, also, what is const expr? What is standard array? It was in C++. And sometimes, and this was not a deal breaker, but sometimes you ran into issues with really complex UI presentation. Trying to do it inside of a synchronous pure function wasn't as straightforward as the old way. And so it kind of took a little bit of massaging to get everything right, but it was not a blocker. So that's kind of how we solved the first issue of app initialization. We had the static mappings. Prefetching is totally controlled by us being infra teams, or app configurations. But the next issue was navigating via like an ID from one module to the next. To get around this, we took heavy use of Facebook's build system. So we have so much code inside of the Facebook app, we don't actually use Xcode build anymore. We use Buck, which invokes the compiler for us and has caching around it so that Facebook builds don't take 10 hours to finish or something like that. It's open source. You can go use this yourself. But the big thing that is not mentioned as one of the main reasons to use Buck, it's kind of like a niche feature on outside of Facebook, is that you are able to query the dependency graph and actually inject code into it, generate it too. And we make heavy use of this at Facebook to solve the issue of the combinatorial explosion, and I'll show you how. So first things first, here's a very oversimplified diagram of what the Facebook app dependency graph looks like. There are tons of features missing, but this is just so you can wrap your mind around it. Here's how this looks in a configuration in Buck. At the top in the blue, you declare a binary called Facebook, and then you list all the deps. These are pretty much modules. Every iOS library is sort of a module. So yeah, you can see on the left, photos is a module. It depends on the friends module, et cetera, et cetera. The nice thing about Buck is that we can put arbitrary metadata in these configs. It's not just name and dependencies. I mean, we can put really anything we want in there. So what we started to do was we started to move things out of the app module files, like constants, like what the module identifier was, and starting to put them into these files. And the reason for that is that once we have this metadata out in these Buck files, we can use it to generate code or to query it. Let me show you why that's important. So let's take profile. First things first, we use Buck and we say, hey, inside of the profile module, dump all the headers and the sources in there. So we get a list. We pipe those file paths to a different tool which analyzes them, looking for all those grab bag of C functions that I mentioned to you earlier. And it outputs some JSON saying, okay, I parsed all those files. I found a module name named photos, and I found a prefetch function and an app function. These are and then since they're C functions, that's pretty much the symbol name minus an underscore. And then once we have all those pieces of JSON about every module, we can do a query and say, hey, go look through the whole dependency graph of Facebook, find all of those JSON files. So we have a giant list of them, and we say, use that to generate those static mappings that engineers did not like manually writing. So as you can see in the blue code, there's like the profile module name, and then a pointer to the function. Because it's a C function, we can just do that. This made our life a lot easier. Engineers didn't have to worry about the static mappings, no more merge conflicts. It's always just generated for you when you build, which is really slick. We took this a step further and we started to use this for replacing or notifying you that you might have a future runtime failure. So you remember this example earlier where you have the groups only app, you tap a photo, and then you try to go to the photos module, but there is no photos module inside of groups only, so you crash. What we started to do is we updated this JSON to include another field saying, hey, just so you know, I inspected the code and groups navigates to photos. So inside of we added another script which goes, interesting, interesting, interesting. So groups navigates to photos, so there must be a module in here whose key is photos. Is there? And if not, Buck would just stop the build and go, hey, I found a problem. Within your dependency graph, there is a possibility that someone is going to try to go to the photos module and you don't have it. So suddenly this runtime failure is completely gone. It's notified during Buck build by analyzing all this JSON we created. If the validation script passes, you just go and generate those static mappings and everything's fine. So suddenly all those missing modules that we had, all those issues of, oh, how do we test to make sure that in every app, every single module that needs to be there is there? Buck is going to tell us by inspecting the code. It's sort of like static analysis. Can't tell you how helpful it was. Last issue, modularity. So now we know all the modules we need, but as we kind of mentioned before, people had took it upon themselves to fix this problem already by making groups just depend on photos. They weren't using the I'm going to travel to the module bot for ID thing. So we didn't quite fix it. There is still this modularity problem. So the way we get around it is we started to go through the app and break up the hard dependencies by introducing navigation objects. So we did away for the like navigate to module with ID API. Instead, we said navigate to a module using this object. So we would create like a photos or a friends navigation object, which had all the information you needed to get to that screen. And then we would create a naming convention around those objects. So when Buck was inspecting it to produce those JSON files, they would say, like, aha, I see that object, and I see you're using it inside of this class. So I know that photos wants to go to profile and friends. So suddenly there's no more arrows anymore between photos to groups. There's only photos to the navigation objects, which have no dependencies. And Buck is generating how to go from, it's like, okay, if I'm trying to navigate with a photos object, I know I go to the photos module. If I'm navigating with a groups object, I go to the groups module. As you can see now, these lightweight navigation objects don't have any arrows pointing back up to the purple module. So we've been able to separate. And the beauty of it is that if you're inside of the groups only app and you're in groups and it says groups navigates to photos and it goes, I need a photo module. Now you can start swapping out implementations. So maybe you don't want the heavyweight photos implementation from the Facebook app. You just want a web view to go to the browser and just show photos, or maybe you want to build a lightweight one, or maybe you want to test them. This allowed us to kind of swap out implementations. And I know that's really abstract and kind of hard to grok just by me explaining it to you right now, but it made a huge difference in app modularity and how we share code. So I'm checking this box off because, yeah, we did it. It might, again, we can talk more about it in the Q&A after or in the follow-up, but this is really how we solved it. Just introduce a little bit of indirection and code generation. So despite all that, we learned a lot. First thing, try to move signal to the left. And what we mean by this is if there's a spectrum of signal, left is like when you get issues about unformatted code in your editor. It's like you hit the save button and it either fixes it for you or it doesn't even tell you, or it tells you right away like something's wrong. The other side of that is like a production only crash. If you didn't see it when you were developing, you didn't see it when you merged your diff, you didn't see it when you were testing your internal build before you released it to prod. It only happened in prod super late. What becomes important to us as we start to add more engineers and more products is you need to move signal about future breakages and bugs to the left as soon as possible. For us, that was all through Buck. Game changer. Second one, be proactive and respond to your API usage. So we didn't really notice that folks were using the initialization method on FBAppModule to do all kinds of prefetching. Not to mention we didn't really have a good API for prefetching, so there was like 2 problems there until it was way too late and startup was a massive problem. And then we pivoted. My recommendation is to keep an eye on how folks are using your APIs and sort of differentiate between how you want them to be used and how they're being used in actuality. And if you see them being used not how you originally intended, you might have to ask yourself, is that okay? Or is it missing? Are we missing something to properly support this? The third point I'd bring up is what we call the pit of success. So this is the idea around if someone is building code and has no idea what you're doing, and they fall into this pit, you want the pit to be like the right way to do it. So you don't want someone who's building a new feature, maybe they're not a full-time iOS engineer or an Android engineer or whatever, and they go, I have no idea what I'm doing. And you don't want it to be easy for them to write poor performing, problematic code, which can, regress all your metrics. You want them to make it easy to understand by default, which is how we did it with synchronous C functions being like, the function's called navigate to screen, and I give you a context and you have to give me back a screen. It's pretty easy to grok from that function what you're supposed to be doing. And there doesn't leave room for you to kind of do it asynchronously or, it's pretty straightforward. I urge you to try to keep doing that. Last thing to remember, product engineers are people too. And what I mean by this is all this stuff is great, but if you notice from the talk, a lot of the solutions we built to solve these problems are not how most people write iOS code. Code generation, C++ mappings, intermediate object indirection, moving away from dynamicism or runtime APIs. This is it's not normal. And you have to respect the fact that when engineers join the company, they could be an expert in iOS development or have built an app at a startup, and then they come to Facebook and we go, we don't use any of that stuff. We have all this different technology, and it makes it harder for people to ramp up. It makes them harder to understand what's going on or debug problems on their own. And so it's a constant trade-off, right? You're trying to move signal to less so that they know quicker that something's wrong, but you're doing it with a technology that they might not be familiar with in the first place. And so there's a constant kind of trade-off back and forth that you have to consider. And the one thing I'll say is the Instagram app has been really great about this. The Instagram app, in comparison to Facebook, is very vanilla. So when you come from the outside, I would say writing something in Instagram feels like native iOS development, but maybe some of the signal might not be as fast as the Facebook app. But then you get into this whole topic of, does it really matter? Anyhow, said my piece. Refactoring FBAppModule, it's come a long way. It looks way different than it does before, but I think we've gotten to a place now where engineers know pretty quickly when something's not built the right way. We've done a great job iterating on error messages so that they know how to fix it and be self-sufficient, and the app is much healthier than it was 5 years ago, and we continue to add more products. So hopefully these lessons translate to something you're doing at home. Good luck, and thank you.